now in this lesson, we'll do a manual calculation of the lighting design for an office. Actually, in industries, we don't do these manual calculations. We always take the help from the software, but we should have the idea how we do these calculations. So we have an office of 10 by 10 area, a height of 2.8 meter. So for this office, we are going to design a lighting system. So first we need to know how much lux required for the office. That depends on the national code book. For different countries, we have different national code books, and as per that standard, we'll select the lux required for this office. And the second thing is, we need to know how many numbers required for this office, and that depends on the various factors we have discussed so far, like area of the room, height of the room, CRI, we have already discussed about it, polar curve, color temperature, IP rating. So depending on these factors, we'll decide the number of lamps or lights required for this size of the room or the office. So let's go to the national code book. As per IECC 2021 lighting standard, for office we use 300 to 400 lux. So we will choose the maximum lux required here. So we'll choose 500. So our lux required for our office is 500. And area of the room we know, 10 meter length, 10 meter width, so 100 square meter. Type of office, that is very important for the selection of luminaires, because there are various kind of luminaires available. We have already discussed suspension type, suspended type, recessed mounted types. So as it is in an office, so there will be a air duct, cable tray above the false ceiling, so there must be a false ceiling. So we'll choose recessed mounted luminaires. And CRI inside office should be 80 and above, and polar curve should be opal curve or parabolic curve. Color temperature should be white, that is 4000 minimum, and IP rating, as there is no risk of having water or moisture inside office, so we'll choose IP20. You can choose more than IP20, IP43 also, but that is not required. The cost will be higher for that in that case. And now we have different company that produce the lights. So we will choose any one of the company as per availability at your place, and depending on these factors, we will choose a particular light. So now let's go to the manual. So I have come to the manual, lighting manual of a Philips, company Philips, and there are different kind of lights. So now let's choose this light. Then I have to check if our condition matches or not. First of all, this light is suitable both for recessed and suspended applications. So our application is recessed mounted. So one condition matches. And the second condition, this is IP20. CRI value is more than 80. Color temperature is natural white 4000 Kelvin. So we can use this light. And its power capacity will be 45 watt, and its lumen value is 3400 lumens. This value is very much important, so remember this value. I will use this value in the next section. And this light has the same polar curve that we wanted, so we'll choose this light only. So this light has 3400 lumens, 45 watt, and all other conditions already matches. You can get the dimension of this light. So let's go to the calculation part again. So already all condition matches in the manual. So now let's go to the calculation part. So now lux required for our office is 500. So far we have got this value from the manual, from the code book, and then now we have to calculate the number of lights required for this office. For that we have a formula, that is E into A by F into UF into MF, where here A is the lux required for the room, E is the area, and F is the total lumen produced by a single lamp. That is 3400 we have just seen in the catalog, and UF is the utilization factor and MF is the maintenance factor, and you have already discussed it before. so we will choose the value 0.4. So now E is 100, A is 500, 3400, so the value will be 36.7. So we will choose this as 36, because while making this you have to keep in mind this number should be even number or prime number. So I am choosing it 36. You could have choose this 37, but 37 will not be an even number. That's why I have chosen 36. So now 36, total number of 36 lights I have to install here in the surface, in the false ceiling. So but how will you install this? For that means how many lights will be in this direction and how many lights will be in this direction. So for that we have a formula also, and that is number of lights on length, means in this direction, will be n. N is the total number of lights into width by length, that will be 6. And the number of light in the width, number of lights on the width will be the same formula, but length will be on the upside and the width will be on the outside, and the value will come 6 into 6. So far we have got the 500 lux required for this lighting for this room to illuminate, and the 6 light will be in this side and 6 will be in this side. So we'll place the lights like this, but we should keep in mind two things. One is this distance, means gap between the two lights should be the double between the gap between light and the wall. See here, the gap between the two lights is double the gap between light and wall. And the second point is ratio of light space and the room height should be less than 1. That means suppose we have a lamp, we have a light here, and this is the room height. So this space, but here this room height is not this side, the light to ground. Room height is the working plane height. Suppose you are working on a table, so that height would be considered, the table height would be considered. Suppose this height is the room height from the working plane to the light, so this height will be h minus 0.8. If we don't have any particular measurement, we basically take this working plane height is 0.8 meter. So this height, ratio of this gap between the two light and the height, this resultant height should be less than 1. These two conditions should be matched while placing the lights like this. So here the h is 2 meter, as the room height was 2.8 meter and this is 0.8, so the h is 2 meter. Suppose we know that room length is 10 meter and we have 6 light, 1 2 3 4 5 6, so 10 by 6 is 1.68, so this gap is 1.68, and we have 1 2 3 4 5 gaps, so 8.4. so total length is 10 meter and this all gap is 8.4. so these two gaps, this gap and this gap, will be 10 minus 8.4 by 2 is 0.8, so this gap is 0.8. so see here, this gap is double this gap. Space between the two light is double the space between the light and the wall. And the second condition also matches here. This height is 2 meter and this is 1.68, so 1.68 by 2 is equal to 0.8, which is also less than 1. So both the condition matches, so our design is successful. And there are a few terms that is very important while designing the lighting system in the software, and that is minimum lux. Suppose we have a lamps here, so minimum lux will be the extreme distance that we have in the floor, and the maximum lux will be the nearest to the point. So the minimum lux is called E min and the maximum lux is called E max, and we have average lux in the room also, that is called E average. And while designing the lighting system, we should always maintain a thing that is called uniformity of light throughout the room, and that is defined as E minimum by E average, and that should be always greater than 0.5. Suppose you have designed a room that's lux is 500, that's okay, but uniformity is not greater than 0.5, then you have to change the alignment of the lights, or you have to increase the light to maintain the uniformity of the lux. So uniformity should always be greater than 0.5. So that's it for the manual calculation. Now let's move on to the next lesson. We'll implement the the whole system in a software will make a building and its lighting system.